Today we will be synthesizing hexaphenyl benzene. The second step of our two-step synthesis of hexaphenyl benzene. Last week we synthesized tetraphenyl cyclopentadienone, and this week we will be doing a Diels-Alder reaction of the compound from last week with diphenylacetylene in order to generate the hexaphenyl benzene. If you remember last week, we had a very dark purple compound. And this week we will be weighing out 0.5010 grams of the dark purple compound. We are not using all of the compound we made last week. This allows that if there's a problem with the synthesis, we still have a small amount of material to go back and try it again. So it's quite common to make a larger amount of the first reaction than you intend to use in the second reaction. We're going to then use diphenylacetylene, which is an alkyne that is a solid. It's a bright white solid, and here you can see that we've weighed out 0.5227 grams of diphenylacetylene. We are going to put both of these in a small 10 ml round bottom flask. You can see that it is 230 now, and we're going to begin to heat with our heating block. This reaction is done neat. However, the two reagents melt together and form a liquid molten material in which the Diels-Alder followed by the second cyclic reaction occurs and carbon monoxide is lost. Here you can see that we're mixing together with our rod to make sure that our materials are well mixed together as the solution begins to heat. And now you can see that we are mixing the solution. It is now 235, and we now have a nice smooth solution. And you can see that this solution is melted well enough together to form a liquid that our stir bar stirs in our solution. We're going to let our reaction go approximately 15 minutes, and at 2:53 we're going to decide that our reaction is done. At this point we're going to use xylenes. You can see that we used about 6 mils of xylenes, and we're going to add the xylenes to our reaction and continue to stir our reaction. We're then going to transfer it to a beaker in order to larger surface area, and we're going to use 10 mils of petroleum ether to wash the beaker and to begin to precipitate out our product. You can see here that this white solid is what is left in the bottom of our round bottom flask after our first washing with petroleum ether. You can see here that we have the dark purple liquid, and underneath the dark purple liquid, if you look carefully, we have this white solid. To collect this product by filtration, and unfortunately we don't have a picture of this, but what we do have a picture of that we are washing this with 3 mils of petroleum ether, and you can see that even though the mother liquor or the filtrate was very, very dark purple, that the compound itself is quite light colored. And here you can see we're going to weigh out our very light pink color. So this tells us that all the tetraphenyl cyclopentadienone either reacted or was removed when we washed the reaction with the petroleum ether, and we have 0.5179 grams of product.